fill out here?
Yes, it's my favorite. My dad's coffee ice cream.
Okay. So within you and your partner, you have 60 M&Ms together, right?
Yeah.
Okay. What you need to do for me is fill out in the observed column how many of each color you have. And then everybody's sum should be 60. Okay. Once you have that filled in, you can eat. Yeah, we just need to track our data. Oh, that's right. You guys are funny with how you eat M&Ms. I forgot. We have a lot of different strategies for M&M consumption. All right. There's 3 of you.
I got one.
Oh, so you should have 20. I want the total. So 3 of them, 7 already.
I put all 30 of them out at once.
Yes, 5, 7, okay.
12. 6 blue.
Right.
20%.
Exactly 6 of each type. So I don't know where.
Oh, that's funny.
Start with red. It's the top of the rainbow.
Yeah, 0.
Red.
Well, then,
I'm starting with orange because there's a
malfunction, orange, defect. We know how to do it. She judges partially.
I'm that person that literally can write into half of them. Oh my god.
Yeah, too much content stuff. He's out. Got it? Okay, guys. Are we okay with the observed column? Okay, what do you think goes in the expected column?
How many weeks do you have?
Yeah, so they tell you the percentages up here, right? 13% brown and red. 14% yellow, 60% green, 20% oranges, 24% blue. So you have 60 M&Ms. You need to figure out, we're not putting the percentages in the expected, we're putting the counts. How many would I have expected to get of the blue based on the percentage? So everybody should have the same numbers in this column.
Oh yeah, how do you look full numbers?
You can go decimals on this. It's okay.
Around 7.8. Oh, that's yeah, I'll do 3. Green is 7.6. Orange 12.
How are you guys doing in the back there? Well, you okay? This back too. Okay. All right, guys. So expected blue. What did you put?
14.4.
Yes. Expected orange. 12. Expected green.
9.6.
Expected yellow.
8.4.
Expected red.
Please credit me.
Expected brown.
You're not getting to the end.
Yeah, they're the same. And guys, that should add up to 60, right? Okay. Are we okay so far? So when we're doing this, we are looking at counts. That's the data we actually care about. It's not the percentage, it's what count we end up with. Okay, now I need you to fill in your observed minus expected column. Yeah.
1.4.
6. No. 8 minus.
Wait, how?
How did 8 minus 9.6? Where did you get 1.4?
Negative. Because it's the 60 add up to the 1.
No, that's just not how that
Wait,
works.
what?
You did 8 minus 9.6 equals 1.4. Negative 1.4. No, yeah, we're all thinking the same thing.
Because, okay, you know when you're doing the subtraction, it's like, it's whatever adds up to the 1, so if it's like 3.7 minus.
I'm just gonna let you talk till you get it, as you will. There you go. Yeah, it's okay. I know what you were thinking, but
Next time.
try again.
See, okay, but then for this one.
Yeah, because it didn't go negative.
That's so cool.
Chrissy.
Yes,
It's also exactly
correct. Yep,
what's 60 minus 60?
agreed.
That's what the why? It's the sun.
All right, guys, once you have your observed minus expected column, can you figure out the next column? You just have to square each one, okay? Observed minus expected squared. Yes, you're going to have decimals. That's okay.
Yesterday, I thought 5.5 times 0.4. I don't know how I got there. It's really driving.
Don't worry, I'll do the math. So, the first one is 2 turns.
We're going to do like the chi-square goodness of fit on your calculator. I'm going to show you where that goes.
Yeah, I know.
Matt, will you fill mark it in here? Okay. Thank you.
I do too.
Yeah, we haven't done anything very complicated yet. Well, you know, subtraction is hard, but other than that. Hey guys, just keep going till you've filled in the entire chart. I think you can handle the last column as well.
Okay.
Okay.
It's pretty good.
I'm sorry.
Guys, you're not going to have to do all of this like by hand in a big chart on every free response. This is just so you understand where this is actually coming from. And you get 8 M&Ms. So.
M&Ms were actually like what I needed to thought like that's just like something.
We might also have a little take back your lifetime today. We'll see.
Really?
Yeah, there's a certain part I want to get through. So.
And guys, we have next today.
Yes, I know that's the reason. But I'm like, I don't need to like crush you on.
It's been a long week.
It has.
Wednesday was the longest day of my life.
Has it been just crazy busy too, like in and out of school? I just feel like there's been so much.
Especially like at the beginning of next week. And it's like you think of the weekend and I'll chill and like take a rest, but you don't. Like I don't have any time to do anything.
This weekend it actually kind of chilled out. But this week was insane.
Right. And I feel like because your mindset is that next week is the last week of work.
Yeah.
That's how it usually is.
I know, and it's not.
And it's not. We can early release when we come back.
Yeah. That's the biggest torture. We have an early release on the Friday and we come back.
I know, it's so weird. It's a weirdly chosen day for that 3-hour release.
Yeah.
I think it's good, and then they were like,
It's torture.
we'll make them suffer.
This week was the longest school week this year. Like it felt.
It just feels really long.
Next week is yeah. Next week
Now the last week is gonna go by.
all that stuff. Like,
I really wanted to snap too, and I'm not sure.
that's not safe.
And
You
last
never know. Maybe it will.
Maybe there's
the
still
last week
hope.
before winter break.
I believe.
It's gonna feel like forever. At least I'm getting all my tests in the week.
I'm so happy they're not on the last 2 days.
Well, yeah, I clearly wasn't going to put it on the last day because that's just not
That's
the
the
day.
I don't even know.
I'm leaving early anyway. The shorter week.
No, because I think you have it in your head that it's going to be very difficult.
Oh, yeah, soon.
All right, guys, how we doing? Does everybody have your chart filled in? I see a few people still writing. That's okay.
I felt like it was Tuesday.
I didn't even realize it was Friday until like Yes.
No, I still know I have another period after before it's actually.
And then I was like,
One more.
oh wait, no.
Then I'm done. But I have like a month. Yes. Yeah, exactly. I was in my house was like yeah. I was 21. No,
Sorry, guys.
yeah. I definitely took a lot of like years.
Oh yes.
Because once you get the first one, it's just a lot easier to do the rest. Except for Virginia. That's just you just can't answer those.
Okay, guys.
Randomly scared me, they're like, oh, it's cool because it's like you.
So does everybody have a sum in this last column? Yes? Okay. That is actually our chi-squared statistic. Okay, so we're going to do something with that now. What we're looking at is how closely projections are to actual. Okay, so like you have these expected ideas. This is the percentage breakdown, what you should get in a bag of M&Ms. We're looking at how closely your sample actually followed those projections. That's what a chi-squared goodness of fit test does. Okay, so let's actually go through this on your calculator. So on your calculator, we're going to pick the chi-squared goodness of fit test. But before we do that, in list 1, you're going to put your observed values. And in list 2, you're going to put your expected values. Does everybody remember how to get to the list to edit? Let me bring my calculator up here so you can see. Yeah, I know. I'm like, I hope you know. That free response maybe didn't go so well. No, I'm so slow at grading those free responses. They take me, like, I'll have them done next class, but the next day turnaround on those is just.
As long as you need, I need to see those.
Should we put the sum on there too?
No, you do not put the sum, okay? You just put your observed, I don't know. Avery, read me your observed, so I have something to put in.
12, 5, 3, 2.
Okay. And then I didn't write down the expected. What were they?
6.
Okay. All right, guys. So you should have your lists in. Are we okay with that? Okay. So go to stat, arrow over to tests, and we are picking the chi-squared goodness of fit test. It's that GOF. Chi-squared GOF. Okay. That's what you're picking. If you tried the other one, it was asking you for values from a matrix. We haven't put anything in a matrice, so. I know, it's very sad. You guys don't, unless you take multi, you don't really learn matrices anymore, do you? Yeah, it's so sad. It's such a useful tool. It's helpful.
One problem in like algebra or something.
Okay, and that was it?
I kind of want to learn the what sounds.
They're very useful. Like systems with more than 2 variables, so easy to solve.
Yeah, we never.
I picked the chi-squared goodness of fit test. So I went stat, test, and then you can either arrow up or you can arrow down for a while. Yeah, I want the GOF, goodness of fit. That's what that stands for. Okay, guys, and it will tell you this where they should be. But did you put your observed in list 1?
Yeah.
Okay, and expected in list 2?
Yeah.
Okay, degrees of freedom. Let's think about this. How many categories are there?
There's 6 values.
Six different categories, right? So degrees of freedom is 5. Let's go ahead and pick draw when we do this. Oh dear.
I got an value. I got an invalid dim.
Oh, I have stuff.
Calling you dim.
Yeah.
Calculators and so
Yeah, that's just not what it's looking like. No idea what it's actually doing. You're creating your own graph sheet. It looks like you created like a line paper. You're drawing this on line paper. It's so sad.
yeah, I'm clearing out other things that might be
Wow, that's a lot of confusion.
yeah, it's,
And I gotta cut it. If you just have it, it gives you the first one and the second one.
I don't know what that is.
I actually like it.
okay. So like I turned off your set plot, I cleared your
Yeah.
Y one. Anybody else getting errors? That's very common.
Let's see. What are the jobs? It's just your calculator being.
Well, you never
Wait, that's not what I'm saying. Wait, Miss Ray. Yeah, do the dotted line.
I don't know why. Good. Oh yes, you can eat. Well, so I don't know if you get mine. This value.
Go back and change it to like and I assume I wanted to watch Oh yeah, I'll look back at it. When the next day, I'm sure I will.
I don't know why. Yeah, I don't know. All right, anybody else getting errors? Yours is not going to look exactly like mine because I didn't put your data in. Okay, I have, yours should look like mine, but other than that. Okay, our picture, it looks a little different now, right? It's not just a normal model anymore or a 2D model, anything like that. It's always going to be this shape that you sketch, and it's always a one-tailed test to the right. It's a greater than one-tailed test. And this is always 0. Okay, so it's a little different than what we've been trying, always. 0, you're going to find your chi-squared value. Okay, so you guys notice this number right here, this chi-squared, it looks like x squared or chi-squared equals what you found as your sum. He's lying to you.
What is it?
Cheese squared. Do you guys see this? Is it matching for you?
Oh.
On yours? Obviously mine's not going to match. Did it match?
Okay. You're just sitting there. Close enough.
Calculator input.
I think probably like this.
Oh, okay. Oh my god. I was like, wait.
That's like, I might have.
How
Chi
is
squared. Are we okay with that? So guys, the chi-squared value you're getting there, that's like a z-score or a t-statistic. That's your test statistic. Okay? What's the what? I'm sorry. Well, it depends on degrees of freedom and all of that. So there's not really like a happy number for you. Okay. And what do you think the p here is telling you? That is the p-value, yes. What does it mean? Yeah, guys, it's like it was before. You compare that p-value to your alpha level, your level of significance, and it's giving you the area that's shaded. Okay? Not exactly. It's just giving you what part of this we're looking at, and what you need to do with it is if it's a really small p-value, you're going to reject your null.
Yeah.
If it's big, you're going to fail.
Are we doing that again?
Yes. So guys, there's more hypothesis testing. A lot of it is the same. You have to write a null and alternative. You have conditions to check. Your mechanics are clearly a little different because you have this little chi-squared formula. And then a conclusion. It's based on the same stuff. Rejecting, failing to reject, all based on your p-value. Okay? So this is actually a unit you guys usually do pretty well on because it's repetitive. It's that stuff again. Okay? The 3 of the 4 steps you've been doing for a while now. There's, well, you know, track.
Oh yeah, that's real difficult.
Just teasing. Okay.
I tried.
Yes, that is what it does. All right, so does that kind of give you a brief overview?
Is that just what you just gonna be like right there?
Oh, that's the goodness of fit part of it, yeah.
No math. I like this.
No math. All right, let me pull up the notes and we'll actually get through a couple of examples here today.
I like it.
Oh.
Wait, no, but like,
I don't have to say that.
We'll get to the homogeneity later. We're not doing that one today.
I don't see any problems.
Like, I may have known how to
Yeah, I know, that's going on the chart.
they need to create a page. And they were like, and then during the test, even if that's funny, they're all like, I don't really want to because there's so many.
Okay, everybody here? Yes.
I like that.
Not so complex. It is a little simple.
I like the one where you're
Yeah. Do you like
That's lessons get the answer.
Does the M&M intro help you wrap your head around it a little more? Because we did that for confidence intervals, and you guys were really good at that game. So maybe I need to always intro with M&Ms. Yeah.
Yeah, and also it's like when I'm interested and I'm tired.
You got some sugar. Now I better make good use of the next, 20 minutes. All right. So chi-square distribution, guys, the shape. Let me draw a couple of them on one. So here's going to be 1. Yeah, and then depending on the degrees of freedom. So guys, this blue one here, I'll say degrees of freedom equals 10. I'm going to draw another one in a different color just on top of this. Degrees of freedom, 20 on that one. Do you see how the lower the degrees of freedom, it's like steeper at the beginning? You're not going to be judged on like, oh, that looks more like the degrees of freedom of 15 than of 20. Like, that's not going to happen. You can pretty much draw the same shape every time. I just want you to understand that degrees of freedom does change what the graph looks like a little bit, okay? But like doing the hypothesis test, draw the blue one every single time. You'll be fine. Okay, so this is always done for a specific type of data. What type of data? We were counting M&Ms by color. What is that called? Yeah, categorical. It is. Categorical.
So never use this on means.
Well, it's different. You're always looking at categories and counts. Categorical spell. And a lot of it is the same process as you've done with your hypothesis test so far, okay? It's always going to be a one-tailed greater than type test. This is always 0. This is going to be right here is your chi-squared statistic. and then the shaded part gives you your p-value. So always one-tailed and greater than, okay? All right, again, we are starting with the goodness of fit test. So it's one variable with more than two possibilities. We were looking at M&Ms and the different categories for the colors of M&Ms.
So the hypothesis, I'm guessing, would be squiggly x squared 0 would be our HO, and our HA would be squiggly x squared is greater than 0.
Kind of. We don't actually do it with symbols. Guys, it's easier to write your null and alternative with these just in words, okay? So your null is that, basically that it follows the predicted value. So depending on, it follows a model that's given to you, like we were given the percentages of the different colors of M&Ms, or like if we roll a die, like all the sides have an equal probability of occurring. Okay, so you just have to use words to tell me what your null is, and then the alternative is just that it doesn't follow that model. Okay, that one of the colors would not have the expected value. All right, so you're still writing a null and alternative, but you're going to use words. Okay. All right, conditions. We are still crossing out this 10% rule one. We do not need to look at that. No. No. We have, looking at scoring rubric after scoring rubric, it just isn't there. So I don't need to make you write it. Okay. So for our last unit, you had to, like if you had independent samples, you needed to say that. But the independence as far as being 10% of the population, like we don't have to do that one. The 10% rule we're not doing. The conditions. So the first one is just slightly different. All expected counts have to be greater than or equal to 5. So you can only do this when the expected for every single category you're looking at is greater than or equal to 5. And then it needs to be a random sample. Okay, so those are the two conditions you have to check. No, that's why it's completely scribbled out. We care about independence from the last unit when we're talking difference of proportions, difference of means, like the independent samples, but as far as this being like less than 10% of the whole population, we're not going to worry about the 10% rule. Okay? All right. And again, these are going to be stated in proportions, like we told you what percentage of M&Ms you should expect. I don't want the proportion, though. I always want the counts. Okay? It's the expected count that I care about. Yes, you need to know this formula. So chi squared equals, what does this thing mean? Sum. Yeah, that's just your summation. Observed minus expected squared over expected. And that's what you did by hand throughout the whole table and the M&M thing. Okay? All right, and degrees of freedom, you figured that out during the M&M thing too. It's just 1 minus, or 1 less than the number of categories that you have. Okay? Not too bad. All right, when you're ready, turn the page. We'll do one. You like this? Feeling good about this? Has a better vibe than the last unit? Okay, good.
The last
Last unit is hard, yeah.
that's the hardest one.
It's just, I think it has the most stuff, yeah. Sometimes the probability units you guys think are just tricky the way it's worded, but what? Probability is annoying, okay. Oh yeah, it turned into, yes. Okay, guys. First example here. This company believes that this is how many customers arrive in their store each day. Okay, so the expected here, it's out of 100, so 10 out of 100, that's just 10%, right? That's what each of these are talking about. 10%, 15%, 15%, 20%, 30%. We're going to ignore that. I'm going to do the total there. So what I want you to do, kind of off to the side here, we're going to fill in observed. And expected. So I'll give you a little bit of time to try to figure this out. Do you see where the observed are coming from? You see the paragraph down below. On Monday, 31 people came. Tuesday, 18 people came. So I'll give you a few minutes here to type into your chart. Does anybody have the old calculator in here? Like just the TI-83? I don't think anybody does, but okay, good. It's much more painful than the old calculator. Or the expected, you can give parts of people. Does that make sense? Like it's okay to have it.
The amount of people?
Yep.
Oh.
Yeah. So you have. Oh, okay. So when you actually try to do, you know, when we do the chi-square goodness of fit test on there, how you nicely just put in what's on the here's the thing. You have to like.
Because the numbers have to be the same.
So it's not.
You use the same sum and find like point
No,
one.
Oh, yeah. So you need like
L1 minus L2.
Like, out of point one,
You do L1 minus
the
L2
expected
squared
percentage.
divided by
But you do it for years.
summation of that. And then your chi-square, yeah, based on the All right, guys. So for Alex, sorry, what's your question? Yeah, so just for calculating the hours, to say that.
Okay, but you just take, so we just send it to
Yes, you're gonna take like 10% time. This isn't like.
Oh, that's percentage, but.
Yeah. Yes. But I think yeah. Yes.
I was very
Yes, but. Did I?
yeah, it's pretty easy. You started doing it right the first two, but the rest you started doing it.
Oh my god. This is my life in
It's okay. No, she did the first two right, and then she started using these numbers.
Oh no!
just cuts, you know.
Just cuz. Alright.
Then if they're 32.25, they should be even because they're like 15%. 32.
That makes a lot of sense.
Yeah. I was like, how's your 101? Then the next one's
It's just how my
that's how you're reading it.
and then it's
Gone downhill.
just kept going down.
Hey, it's Friday. Alright, is everybody okay with the observed and the expected? Yes? Okay. In this last column, what I want you to do by hand is to actually find the chi-squared. So you're going to do observed minus expected squared divided by expected. Okay? So you're going to do that for each individual one, and then you're going to give me the sum at the end. Excuse me.
Observe my expected square.
And then we're gonna see if I get the same. I'm gonna do this.
I'm going to write what the total should be, and we'll see how you do. So actually try it. Make sure you can get to that total. So you're going to do 31 minus 21.5. Square that, divided by 21.5, write down that number. Yeah, just do it all on your calculator, though. Don't, like, write down each individual step. Just do it. Okay? Like your first one, yeah, Nike it, okay. Your first one should be 4.2. Okay, I rounded the 4.2.
We're all saying divided by the wrong.
It's supposed to be squiggly, yeah. So all it is,
We'll just say crowbar. Alright, yeah, crowbar square.
I'll look at it.
And why is that?
Why?
How did it become a thing since it's somewhere to
Yeah, I just quickly have
No. Yeah, like extra squiggles.
I've been doing it since like 6th grade.
You did not know how crucial they were to the statistics world, did you?
I didn't know that. I actually started doing this because I had this competition with one of my classes who I was like to finish math the fastest in elementary school. And so we both had to like make sure that we were the coolest. We both did squiggly activities. We were different on the whole crazy.
You're in your own little bubble.
Yeah.
That's alright.
Yeah.
Owning yourself. I like it. Yeah, Mallory. Oh.
This is before Mallory.
Oh, definitely. How we doing, guys? Who knows? Okay.
So the sum of this
Is the chi-squared. Yep, that's your new test.
so is Campbell was fine with that going in or by
Yes. Oh yeah, and that's your test. They're not the cheapest. Yeah, it's a June round.
Uh,
I didn't get that, so I got 2.7.
I don't think I can have this.
Guys, rounding, you might be slightly different from what I had, but are we really close to this 8.5?
Oh, it would be negative.
8.774. Yeah, I think I might have screwed up more than rounding.
Yeah.
So 4.5.
Let's try again.
Yeah.
By 64. No, it's 4.5. But either way, it's still 1.3.
Did you try to-
Oh, I didn't. I didn't.
I don't know where I got this.
You divided by the wrong thing. 30 minutes? I stuck it. I've done 64. I divided by
Yeah, we just forgot to swear it. Guys, you can't do all of them on your calculator and just write down what the values are. Your calculator will do list 1 minus list 2 squared divided by list 2, and then you store it in list 3. You have all of them.
How do you make it, how do you like put it?
So, attachment 22. So if you go somewhere here, 3, 2, okay. Squared divided by 2, right? 4. Okay. Yep. Another minute here to make sure you guys are there. Now guys, again, you're gonna do the test on your calculator, but I really want this formula like ingrained in your head, okay? Observed minus expected squared over expected. All right, so are we okay with that 8.54? Okay, now let's, oh, okay.
One moment. Yep.
Okay. All right, so let's write our null and all our alternative. I can't talk today. So for the null, like what I would write for this is something like the company's customer projections are correct. And what do you think the alternative would be? Yeah. And the only other thing we'll add to it, so the company's customer projections are not correct for at least one day, okay? Does that make sense to you, though, contextually, what we're doing with the null and alternative? You could do it as symbols, but it's pretty painful to do as symbols because you have to write out, like, proportion for Monday equals 0.1, proportion for Tuesday equals 0.1. This is easier. The words are actually easier. All right, conditions. What is our first condition? Okay, SRS. Does it actually say it was random? Randomly chosen. Okay, it does. The week was randomly chosen, so we'll say yes. We can say stated. Oh. Exciting conclusion after lunch, guys. Conditions. We talked about random. What's the other condition that has to be met?
Has to be like greater than or equal to 5.
Okay, what has to be greater than or equal to 5? All expected counts.
You just put like a check mark next to that?
You just say, yeah, all expected counts greater than or equal, or are greater than or equal to 5. Okay? All right. What I want you to show from here is the formula for chi-squared. What is the formula for chi-squared?
Sum.
Yes.
The sum of O minus E squared over E.
Okay. Observed minus expected squared.
Over expected.
Okay. Yes, I want you to write that formula.
Every time.
Yes. And guys, if it's not a very large group like this, I want you to actually do the chi-squared values like we did in the table here. Okay? If it's a whole bunch of values, no. But if it's not that many, yes. Okay? But then go ahead and check it on your calculator too. So put that into list 1 and list 2. If you haven't already done that, try that and see what your calculator gives you for your chi-squared. So I want everybody to go through the practice of that again and the draw function to make sure you see what you're supposed to see. Everybody know where I am? Okay, what's in list 1? Observe. What's in list 2? Okay, and then on your calculator, do the test of the chi-squared goodness is hidden. And take a draw at the bottom. See what you get.
Oh, this is fine.
What's the difference between 1, 2, 3, 4, 5?
Mine is already plugged in. Like, I didn't have to plug in list 1, list 2, or 5.
That's like the default. Yeah, and
It's like
then
the standard deviation and mean.
so like if you did something weird and stored it in list 5 and list 7, then you would have to change that. But as long as you just do observed in list 1, expected in list 2, will always be set up right.
And then
Yeah.
see, I'm like, oh, this is wrong.
Yeah, we're gonna make sure. That's next. Okay, then calculators are ready. Yes. Any calculator trouble?
Oh, I gotta ask, so is that a condition? The summation?
No, that is like your test. That's the kind
So we already have that with you, so we just work with this good. We're just telling us to do with the calculator.
And if it's like a 8%,
So that's our equation that you write down.
for those three conditions, the one alternative, yeah.
Well, you have to change that.
Well, it's square.
So wait, the expected is an L.
You guys gonna do calculator?
Here? Yeah. Form. Feels like my bedroom.
Yeah, I feel like I'm already in.
Did you get 8.54?
C.
Yes? Write down your degrees of freedom too. How many degrees of freedom?
5.
5, good. And what was your p-value?
1.1 to 88.
0.1288.
Can we just like leave P equals 1.138, like pointing at the drawing and leave it there? Or do you want us to write out as well?
I like you writing it, but. And guys, then your picture. 8.54. Standing over there. What do you think? Do you need a sketch on these?
Yes.
Yes. Okay, draw the picture. All right. Are we all okay through this point? We're through like 3 of the 4 points on your free response. Yes. What is left?
The
Conclusion. Looks a lot like what we've been doing. So, since our p-value of 0.1288 is, what am I comparing this to?
Greater
Okay, greater than what?
alpha.
Good. We fail to reject. Fail to reject. No. It's looking familiar, right? Okay. There is not enough evidence. I can't write. To suggest. Did I say to prove? No. To suggest that the company's projections are not correct. Read through that again. Take a minute to make sure that makes sense to you contextually. Questions on any part of it?
What is the, for your HA, you said it's for at least 1 year,
Yeah,
but you don't say that.
you could absolutely include that are not correct for at least 1 day. That would be, you're basically just writing the alternative here. Yeah. Okay. How we feeling? You like chi-squared a little better than last unit so far? Yeah? Okay. I'll get the M&M. All right, that's where we're stopping today. Oh, yes, I know.
Is it the
Yeah, you can turn up